How do we find the units of energy? Let's look at this section here. How do we find the units of energy? Okay, the unit of energy basically is equivalent to unit of work done. Do you still remember in the topic of work, energy, power? The energy and work done, they are the same thing. Work done means energy input or energy loss, depends on uh, the force we use, right? Now, energy, the unit of energy is the unit of work done. So what is the formula that relates to work done? Work done is equivalent to force times the displacement, and both of them must be in the same directions, right? Now, what is the, can we continue to expand? What is the formula that relates to F? F equals to MA times D, right? So when somebody is mad, that means that person is very energetic. Okay, please remember this one. Okay, now what is the unit for mass? Kilogram. What is the unit for acceleration? Meter per second square. What is the unit for displacement? Meter. Displacement is length, right? It's just a vector of length, so it's in meter. So the answer is kilogram meter square per second square. Okay, now let's look at various options here. Let's look at option A. Will this G rho H V, okay, their unit, will it be equivalent to this one? If yes, this will be the answer. Let's check. G, what is G? G is gravitational field strength, is newtons per kg. By the way, newtons per kg, we can, you know that this one, but you see this one is all in SI base units. So this one is not in SI base unit. Let me convert it to SI base unit. Okay, newtons per kg actually is equivalent to meter per second square, because you still remember the unit for gravity definitely is meter per second square, right? So we do not use this one, otherwise it will be very difficult for us to solve the problem. So G is meter per second square. Density is kilogram per meter cube, kilogram per meter cube. H is meter times meter. Volume is meter cube. So this one will be meter times meter power 4. So meter power 4 times meter power 5 divided by meter power. So this one, obviously the answer here will not be equivalent to this one, so we do not need to check further. A is out. Look at option B. What is the unit for rho G square H? Okay, rho, okay, density kilogram per meter cube, kilogram per meter cube. Now we speed up a bit. G is meter per second square, we square it. H is meter, so it becomes kilogram per meter cube. So this one we square it, so it becomes meter square s power minus 4. So it becomes meter square divided by s power 4 times meter. So this one meter square meter cube, meter cube can cut. So this one become kilogram s power minus 4. Again, they are different, so this is not the answer as well. Let's look at option C. What about rho HV over G? Will you get the same answer as that one? Density is what? Density is kilogram per meter cube. H is meter. V is meter cube. Divided by G. Divided by G. G is meter per second square. Meter per second square, I bring above, become second square. I hope you can see that. G is meter per second square. Per second square, I bring it up, it becomes second square. So this one cut, 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 cut. So it's kilogram second square. Again, it looks different. So it will be out again. Okay, look at option D. Now, what about unit of rho G over HV. Rho is again kilogram per meter cube, right? G is meter per second square. Divided by H. Divided by H means divided by meter. Divided by volume again, meter cube. So meter, cut meter. So it's become kilogram meter power minus 6 s power minus 2. This one wrong as well. Okay, let's come back and check this one, whether this one may be correct answer. Meter per second square. Let's check. Meter per second square. Kilogram per meter cube. Meter power 4. Meter times meter cube is meter power 4. So meter cut. So this one become kilogram meter square s power minus 2. Okay, answer is A. It was a mistake just now. I didn't proceed further. The answer is A.